Interesting modulus function question here. Now, if we just had, say, 3x minus 1 with the modulus around it is equal to x plus 2, when I teach this topic, I always say sketch the graph, okay? We got the critical point at 1. It's going to go through 3. It's going to look a bit like this. And if I do x plus 2, it's going to have a slightly shallower gradient. It's going to go have a higher y-intercept, so maybe something like this. And we can see there would be two solutions. And then we can just take plus or minus of the modulus and obtain them. Now you have to be really careful, and this is why a sketch is good, because sometimes you get spurious solutions, and we're going to see that in this example. In this case, it's not going to be beneficial to try and sketch this. In the process of sketching it, we might as well have just solved it. So going to skip that. We're going to take a slightly different approach, but it's going to use similar sorts of ideas. The first thing I'm going to do is work out the critical points and therefore the intervals I need to look into, because each modulus function is going to behave slightly differently depending on where we are. So we have a critical point of -1 for this modulus function when it's, and actually I'm going to write down what that means. So y equals the modulus of x plus 1 is just going to be x plus 1 if x is greater or equal to -1. The modulus function does nothing here because the inside the modulus is positive, but it'll become minus x minus 1 if x is less than -1. That's when it kicks in. So -1 is the critical point. And we can do it for all the other ones. So modulus of x, and I'll ignore the, I could include the minus. I think I'm going to ignore it. So y equals the modulus of x is equal to x if x is greater or equal to 0 minus x. Technically, I should put, this shows it's a piecewise function. Okay, and then it's minus x if x is less than 0. Okay, next one is a critical point of 1. Just realized I've put in too many critical points. Get rid of that one. So y equals 3 modulus x minus 1. Actually, we can bring the 3 inside. That doesn't affect whether it's negative or not. And then it's going to be 3x minus 3 if x is greater or equal to 1, minus 3x plus 3 if x is less than 1. And finally, this one will have a critical value of 2. So it'll be 2x minus 4, the modulus of, which gives 2x minus 4 if x is greater or equal to 2, and minus 2x plus 4 if x is less than 2. So now we're going to deal with each interval in turn and see what solutions we get. So first up, interval number 1 is going to be x is less than -1. In this case, the modulus is kicking in for all of them, actually. So I'm going to get minus x minus 1, and then I'm minusing minus x. Actually, it becomes plus x. Then it will be minus 3x plus 3. And finally, I'm minusing the minus 1, so it will return to being plus 2x minus 4. And that is going to equal x plus 2. You can cancel out the x and the minus x. Then we've got minus 3x plus 2x. That's going to give me minus x. Minus 1 plus 3 is 2. Minus 4 is minus 2. That's going to equal x plus 2. So 2x equals minus 4. X equals minus 2. This is in the range that we're interested in, so this is a valid solution. I could even extend it to less than or equal to 1, but it doesn't actually matter really, because at that point, whichever one is kind of being affected would just be 0. So I think I will. Right, next region is going to be here, number 2, between -1 and 0. Because what we're going to see now is that this one here, we're going to be, is the modulus isn't going to be kicking in. We're just going to get x plus 1, but all the rest of them will be. So you can see how things are going to change as we go along. So I've got, sorry, I've got -1 is less than, because I've already included minus 1, x is less than or equal to 0. Okay, it's going to be very, very similar, but this time it's x plus 1, and then all the rest is going to be the same. I'm going to write it down. Okay, so what happens this time? The x's do not cancel. We've got 2x, and we've got minus x. It's going to become x. And then again, on the left-hand side, I'm going to have minus... No, I'm not going to have minus 2. I'm going to have 0, actually. So x is equal to x plus 2. That's what I get. And actually, this has no solutions. This is not possible. So no solutions for region 2. 3 intervals left. So next up, I'm going to do 0 to 1. Okay, this time the x plus 1 stays as it is. The x will also stay as it is, so it's actually going to become minus x. Let me bring the whole equation down. And then I'm still going to get minus 3x plus 3 plus 2x minus 4 equals x plus 2. So again, here the x and the minus x cancel. We're back to having minus x. But what's going to happen here? We're again going to get, so the 1, 3 and the minus 4 are going to cancel. So it's minus x equals x plus 2. And that means that 2x is going to equal minus 2, x is going to equal minus 1. This is not in the range that we're interested in. So it's a solution to my equation that's in red, but it's not a solution to the whole system. So this is spurious, and I would reject it. Okay, let's take a look at 4. So that's going to be 1 is less than x less than or equal to 2. So now everything, the modulus is that they're going to be positive. Like this one's going to be positive when I put my value of x in. So I will get x plus 1 minus x, and then it'll be plus 3x minus 3 instead of the minus 3x plus 3. I still get plus 2x minus 4 here, and then that is going to equal x plus 2 as before. Cancel these. The 1, the minus 3. Oh, wait, that's not. No, sorry, this is different this time. So we're going to get minus 6 for 5x minus 6, I believe. 3x plus 2x is 5x. 1 minus 3 is minus 2. Minus 4 is then minus 6. 5x minus 6 is equal to x plus 2. That means 4x is going to equal 8. X is going to equal 2. And this is valid, actually, because I included that less than or equal to. So yeah, I could potentially have missed that if I hadn't have. But when I do region 5, I could alternatively have done x is greater or equal to 2 there. And I then find it. But I'm going to go with x is greater than 2 now, see if there's any more solutions. Right, so finally, number 5 is going to be x is just greater than 2. Out with that, now we're here. So they're actually, the modulus doesn't, I can just get rid of it in each case. X plus 1 minus x plus 3x minus 3 minus 2x plus 4 is going to equal x plus 2. I'm left with x. I combine these. 1 minus 3 is minus 2, plus 4 is going to be 2. X plus 2 is equal to x plus 2. This is actually valid for all x in the interval. hence x is going to be greater than 2 because that is my interval. And then to wrap it up, so overall, we have from the very beginning, x is equal to -2. Or x is going to be greater or equal to 2. So a nice question on the modulus and modulus equations here, just to show you this is what the graph would actually look like. If I plotted the left-hand side, we get this red function. And so you can see here is where it intersects the other function, y equals x plus 2, the blue function. And then when we get to x equals 2, they actually just match up perfectly. Well done.